Today we're going to be talking about the law of cosines. This is similar to the law of sines in that we use it when we have non-right triangles. But we use the law of cosines when we can't use the law of sines. So if I'm looking at this triangle here, if I was going to use the law of sines, I would need to have an angle and a side opposite each other where I know both of those. I don't have that here. The only angle I know is angle B. I don't know what side B is. So because that was my only potential pairing, it's not like I have angle A where I could then do a little bit of subtraction to figure out what C is. I cannot use my law of sines. So what we're going to do is we're going to come in with this law of cosines. And so this particular triangle is one that would be a side angle side. I know two of the sides. I know the angle in between. And I can use law of cosines on side angle side. I can also use it on side. So if I know all three sides, and we'll do an example of that in a little bit. But the law of cosines, we have it right here, starts off looking like Pythagorean theorem. There are three different versions of it, and it all depends on what angle side we're trying to find. But it looks like Pythagorean theorem, especially if I look at this last one here. This last one here looks most like Pythagorean theorem, at least the first half of it does. It's c squared equals a squared plus b squared. But because it's not a right triangle, I can't just use Pythagorean theorem. I can't just use c squared equals a squared plus b squared. So it's c squared is equal to a squared plus b squared minus 2 times a times b times cosine of c. And that's just one form. That's the form that uses angle c, and then side c is all alone on the other side of the equal sign. It's the similar pattern for angles a and angle b. Because this is a more complicated formula than law of sines, you don't need to memorize this. You do need to know the law of sines, but you do not need to know the law of cosines. On your test, I'm going to give you this formula. But we're going to use it. So we're going to go back to that original triangle that we could not use law of sines on, and we're going to use law of cosines to find the value of b. And because I'm looking for the value of b, the form that I want to use of the law of cosines is the one where b squared is by itself. So b squared equals a squared plus c squared minus 2ac times cosine of angle b. That's the form of the law of cosines that I want to use. The reason I pick it is because we're looking for side B, and this is the form where side B is all alone. B squared is by itself. So what I want to do now is I just want to fill in what I know. I don't know B, so that's going to stay as B squared, but I know what A is. A is the side across from angle A, so that's 22. So this is going to be 22 squared plus side C, which is 10 squared, minus, and this is where I want to be a little careful with my parentheses, 2 times 22 for that side A times 10 times cosine of angle 44. And now I am in degrees, so I do want to make sure when we get to the calculator part, my calculator is in degree mode. But figuring out what form you're using and then plugging it in, that's the very first step. Now, how complicated it is to solve, fully dependent on are you looking for a side or are you looking for an angle. Looking for a side is much faster than looking for an angle, because what I can do is I can take a look at the right-hand side of this equation here. And I can look at this, and after I plug in all my things, I can say, does that side have any variables? No, no variables. If this side has absolutely no variables, then we can go straight to our calculator. No variables means I can go to the calculator, straight to the calculator, which should be, or if it's not, make sure it is, in degree mode. Most of the time, vast majority of the time, when we're doing a law of sines or law of cosines problem, we want to be in degree mode. But because this has no variables, I can type it in exactly as I can see it. Open parentheses 22, close, squared. Plus open parentheses 10, close parentheses, squared. minus 2 times in parentheses 22 times parentheses 10 times cosine 44. Hit enter, and we end up with b squared equals 267.4905. We want to keep like 3-4 decimal places because we aren't quite done. We are so very close to being done, but we are not quite done. But most of the problem is finished. Okay, there are no variables on the entire side of the equation, so we could put it all into our calculator and we get this number. We just need to do one little thing. We don't have b equals, we have b squared equals. So I need to undo the square. So take the square root of both sides. We do that, and we get that b equals 16.355. Right now, it doesn't really matter how far we round. On WebAssign, it will be very clear, and on your test, I will tell you how many decimal places that we want. But that's our side length. So using law of cosines, if you're looking for a side, is a lot of calculator work. Typing it into your calculator, and then the key thing at the end is remembering to take your square root. So we're going to do one more of these. We're going to look for the length of AC, which for our purposes is the same thing as side C. That's what we're looking for. So when we do this, we want to use the form of the law of cosines where c squared is by itself, because that's what we're looking for, is side C. So this is the one that looks a lot like Pythagorean theorem, at least the first half does. So c squared equals a squared plus b squared, but it's not a right triangle, so I have to include this minus 2ab times cosine of angle C. Okay. So what I want you to do is I want you to try and plug in all your values that we know and see if you can solve for C. So take a minute using this formula here and the values we know from our triangle. Try and figure out what the length of C is. All right, so plugging in all of the values, little a is 13, little b is 12, and I just now realized that I put those in the wrong order, but it truly doesn't matter if we switch up the A and the B order here. And 134 for angle C, we get something that looks like that long red line. And there are, again, no variables on that entire side of the equation. So that entire long side that's underlined by the gray can go in your calculator. Type it all in, be careful with your parentheses, make sure you're in degree mode, then you should get 529.733 with a couple more decimal places at the end there. But that is, if you tried to give the answer is 529.733, that is way too long for that triangle. And the reason why is that's not C, that's not the side length, that's C squared. So you do need to remember, and it's so very, very easy to forget to do this, but you do want to remember that you have to take that square root. So C is equal to 23.02. Okay, so finding the side length, complicated in the sense that it's a long formula, but it's a lot of calculator work. When you are asked to find an angle value, this is where it takes a lot more algebra before we get to the calculator. So still want to pick one of my forms, and since I'm looking for angle C, I want to pick the form that starts with C and uses angle C. So it's the same form we just used. C squared equals a squared plus b squared minus 2ab cosine C. And just like before, I do want to go through and I want to fill in everything I know. So instead of c squared, I do actually know little c. Little c is 11, so this would be 11 squared equals little a, which is 10 squared, plus little b, which is 17 squared, minus 2 times 10 times 17 times cosine angle C. And just like we did on the last two problems, I want to look at the right-hand side and say, does that side have all variables or have all numbers? Does it have any variables? And unlike the last two problems, this time we should say yes. There's still the variable angle C. And so this time, since it has a variable, I cannot go to my calculator. I can spell variable. I can't go to the calculator, so no calculator just yet. We will get to it, and we're actually going to use it in a little, like very soon in other ways, but we're not just going to plug everything into our calculator. We have to spend a little bit more time doing some algebra. Okay, so we're going to clean up some of our numbers here. We're going to clean up some of our numbers. I want to square the 11, get 121. Square the 10 gives me 100. 17 squared gives me 289. And then while I can't do any subtraction yet, I can multiply -2 times 10 times 17. I can multiply that together, and get -340 cosine angle C. And it might be very, very tempting to add and subtract all the numbers on the right-hand side. But this right here cannot be broken apart yet. I cannot do subtraction just yet. We are close, but we cannot do it. This right here in this big purple box, that is a package deal. So what I want to do is I want to combine the first two together. And I get 121 equals 389 minus 340 cosine of C. And just like before, this is a package deal. I want to separate it. So I need to be very careful that I don't accidentally subtract my 340. But what I want to do is I want to solve. I want to get that purple box alone first. Before I can get to C alone, I need to get the purple box alone first. So we're going to do some algebra. We're going to subtract 389 from both sides. And if we do that, we should get -268 on the left equals, now I've got just the purple box, -340 times cosine of C. And this is starting to get into what we talked about a little bit last week, very briefly last week. I am going to want to end up getting cosine of C alone so that I can do some inverse cosine. So in order to do that, we're going to do some division. I'm going to divide and divide by -340 on both sides. And I'm running out of space, but hopefully you can follow along. I'm going to do it over here. And we get that some decimal, specifically the decimal 0.7882 is equal to cosine of angle C. So that fraction, -268 over -340, gives 0.7882. That's what cosine of C is equal to, and we are almost done. I have one last step to do. I want to get C alone, angle C alone. So the way we do that is we're going to use our cosine inverse, 0.7882. That's going to give me angle C. So if I do cosine inverse of that wonderful decimal, we should get that angle C is 37.98 degrees. It is a lot more difficult and a lot more work to find an angle value because I can't go to the calculator and just type everything in. You do have to go through the process of finding a lot more of those individual pieces, and there is absolutely no way around that. You just have to do it. And it is very easy to make a mistake with that subtraction in front of the cosine C. That is the most common way to make a mistake in this. So when you are asked to find an angle value, you do need to be very careful when you're going about finding an angle using the law of cosines. But you can do it. All right, in this question, we're looking to solve the triangle. So you want to find all of the missing sides and all of the missing angles, just like we did last week. But just like the triangle we had at the very beginning, we don't have a matching pair of sides and angles in order to use the law of sine. So we do have to use the law of cosines. So I do want to, just like we did before, make a little list of all the things that we need to find. we need to find side length B, angle A, and angle C. And so usually if you're making a list, if you're stuck on which form, law of sines, law of cosines you're going to use, if you're listing off what you need to find and two of those are angles, more often than not, you're going to have to use law of cosines. But we want to start by doing the easiest one first. So we're going to start by finding side length B. So I'm going to use the form B squared, the one that's B's all alone, equals A squared plus C squared minus 2 times A times C cosine angle B. And just like every other problem we've done, we want to go and fill in what we know. Don't know B, so that's still B squared. But I know side A is 16 and side C is 25. So I can fill those in. And I do want to be careful with my parentheses. And I know that angle B is 97. And so just like every other one, we're going to look over here. We're going to look at the entire right-hand side and say, okay, any variables in there? And since there are no variables, that means we can go and plug everything into our calculator. So doing that, being careful with those parentheses, we get 16 squared plus 25 squared minus 2 times 16 times 25 cosine 97. And we should get that our B squared is equal to 978.495. Again, if that number looks giant to you, that's because it's B squared, not B. So we do want to go through and take the square root of both sides. And if we do that, we get that B is equal to a much more reasonable 31.28. So I want to go put that in my list. B is equal to 31.28, and that's really helpful, and that's going to be used to help us figure out my other sides, or excuse me, my other angles. We know all the other sides. And so I'm going to erase this work here because I need that space, but hopefully you've got it, and if you don't, you can pause and get it all down. But now I want to look at my new triangle with my new information. And so I'm actually not just going to put it in my list. I'm going to put that side length on my triangle. So this side length here of B is 31.28. And now I've got to find angle A or angle C. And so to find either of those, it's going to be about the same amount of work. So I'm just going to pick one. And so I'm going to pick angle A. That's what I want to find first. Before I get too far along in the process, I want to take a step back and say, okay, can I use law of sines or do I have to use law of cosines? Because finding an angle using law of cosines is a lot of algebraic work and is not always the most fun. So if we can step back and we can use the law of sines, we want to. And so remember the qualification, the requirement for law of sines is that we have an angle and the side opposite where I know both pieces. Since we just found side B, we know both pieces now. So yes, we can now use our law of sines. So that's what I want to do. I want to set this up with sine 97 over my newly found 31.28 equals sine of angle A over side length A of 16. And I want to do my cross multiplication. So we'll cross multiply. We would get some wonderful numbers. We'd get 31.28 equals 16. Oops, hold on. 31.28, I didn't actually cross multiply. Times sine of A equals 16 times sine 97. Okay, to solve for angle A, I want to start by getting sine of A alone. So to do that, we're going to divide by 31.28 on both sides, divide by 31.28, and we get sine of A is equal to this great fraction, 16 sine of 97, all divided by 31.28. And it's hard to see on top of that. But I want to take this and I want to put this into my calculator. So in the calculator, be careful with those parentheses and those sign. We get 16 sine 97 divided by 31.28. And we would get 0.5077 if I rounded there. So that gives me, if I go back up here, sine of angle A equals this 0.5077. And we want to solve for A, so we use our sine inverse. A is equal to sine inverse of 0.5077. And in our calculator, that tells me that A is equal to 30.51 degrees. Okay, so even though we didn't use the law of cosines, we still had to do quite a bit of algebra, but it is less algebra than the law of cosines. Law of sines is almost always going to be faster and easier than the law of cosines. There are times, like for finding side B, we cannot avoid it. But if you can use the law of sines, it is almost always typically faster and easier to do so, even if you have to go through the process of doing the inverse. But I know another item on my list, so I can go fill this in. This is 30.51 degrees, and so all I'm left with is one angle. If I take this 30.51 degrees and I put it in my picture, it might be a little bit easier to see how to find that last angle of C. And you can go through and you can do law of cosines, and you can go through and you can do law of sines. But the fastest way, the easiest way is to look at this and say, okay, I have a triangle. Triangle angles always have to add up to 180. I know two of my triangle angles are 97 and 30.51. So if I do a little bit of a subtraction from 180, we would get that angle C is 52.49 degrees. Okay, so as we went along, each of those next variables became slightly easier to find, and that's usually going to be the case when you're solving a triangle. So the first one tends to be the most involved. Not really in this case, because we did a lot of calculator work with that, and we had to do a little more algebra work with the second one, but that last one was significantly easier than the other two. All right, we have one more triangle to look at, and this is actually 3 triangles in one, and so we're going to have to do some multi-step processes, but we're trying to find 2 values. We're trying to find the value of x, which is an angle, and then we're trying to find a side length of y. We're going to start with trying to figure out what x is, and so in order to do that, I'm going to focus on just this triangle here. Just the one single triangle that involves my x. So I'm going to focus on that right there, and I'm going to look at that and say, okay, I want to figure out what x is, which I'm going to also call angle B, just to be a little bit more consistent with what we've been doing in the past. And I've got angle A and angle D in this triangle. C is a part of the other triangle. I've got an A, B, and a D. So if I go and I fill in my side lengths here, 42 is side B, 50 is side A, and then 32 is side D. So looking at that triangle, I know all 3 sides. It's a side, side, side triangle. I don't have an angle side pair, so I can't use the law of cosines. So I do need to use the law, or excuse me, I can't use the law of sines. So I need to use the law of cosines. And so when I go to set this up, I am going to do it a little bit differently. I'm trying to find angle B. So I do want to use the one that's B squared, but I don't have a C, I have a D. So anywhere where I had a C before, it's going to be replaced with D. So this is A squared plus D squared minus 2AD cosine of angle B. And just like before, we want to fill in all we know. Now I know B, so that's going to be 42 squared. I'm going to end up with some very large numbers, but that's all right. A squared is 50 squared plus 32 squared minus 2 times 50 times 32 cosine B. And just like every other problem, we want to look at this and say, do I have any variables on the right side? And we do. We have that variable of angle B. So I can't go to my calculator. We have to do the long process. We have to do the algebra. So we're gonna multiply some things out. We're gonna figure out that 42 squared is 1,764. 50 squared is 2,500. 2,500 plus 32 squared is 1024 minus, and I am going to multiply this 2 times 50 times 32, and that's going to give me 3,200. But that is times cosine of B, so I'm going to put my big purple box around that, because that's not going to get broken up until the very end, almost the very last step. But what I can do is I can combine all my other numbers. I can combine the 2,500 and the 1024, and that's going to give me 3,524, and then we can subtract that. So I'm going to write it up at the top here. We now have a new line, 1,764 equals 524 minus 3,200 cosine B. All right, so this is just to give me a little bit more space. There's my big box. I can subtract, so there's that line there. I can subtract the 3,524. So I do my 1,764 minus 3,524. We get negative 1,760 equals negative 3,200 cosine B. Now I can start dealing with that coefficient of negative 3,200. Now I want to break that apart, but I can't break it apart by subtraction or by addition. I can break it apart by multiplication or division. So since that's a multiplication in there, we're going to divide, and we are left with 0.55 equals cosine B. And there's no rounding there. That's the exact fraction, which is kind of nice. You don't have to worry about rounding. And then we have one last step to do to figure out what B is. We do cosine. So to do cosine inverse of 0.55 gives me angle B. When we get, if we're in degree mode, 56.6 degrees. Okay, so we just did a lot of work, and I kind of wrote all over that picture there. But we get, just like we did a couple examples ago, we have to go through this whole algebraic process. There's no real shortcuts to this. But I'm going to go put that in my picture for where it is. This is my 56.6 degrees here. That's my angle. That's my x value. So up at the top, I'm just going to write that. X is equal to 56.6. And I'm going to do a little bit of erasing. I'm going to erase this work so we have more space to write for y. I do want to go through and I want to find y, but y is a part of the other triangle, triangle CBD. And I know angle C is 51. But I don't know anything else really inside that triangle. I mean, I know side C is 50, the one across from C. So this is also going to be little c, because that's across from angle C. And then y, it can also be called side D, because it's across from angle D when I'm looking at the second triangle here. And it's really important that we be careful about when we're talking about which triangle and what the C's and D's and all those things are. But if I'm looking at the triangle on the right-hand side, then I can look and I can say, okay, I know C, angle C, and I know side C. So I have a pair, which means really likely that we're going to be using law of sines. but I don't know the angle across from the side I'm trying to find, and that's important to use. You have to know the side across from the angle or the angle across from the side that you're looking for. So I want to see if there's anything else I can do to figure out some pieces in that triangle. And so what we're going to do is we're going to use that angle we just found of x, and I'm going to look at the angle next to it. And those two angles together create a line. They are called a linear pair, which means those two angles together have to add up to be 180. So if I take 180 and I subtract our newly discovered 56.6, we get that this angle next to it, the one by the capital B there, is 123.4. And that's going to be very, very helpful because that's going to allow me to find this angle up at the top for D, the one across from that side we're trying to find. Because I can take that 123.4 and I can add 51 and I can subtract that from 180 because it is a triangle and triangles all add up to 180. And I can get that the angle up at the top, it's tiny, is 5.6 degrees. And now, not only do I have a pair of C's, I have a 5.6 angle across from the side I'm looking for, and so we can use law of sines. So that's what we're going to do. We're going to do sine of 51 degrees over 50, because that's the side across from it, equals sine of 5.6 degrees over y, or d. You can use d or y. I know we're not used to having angles quite that small, but it's possible you can have an angle as small as we want as long as it's still positive in a triangle. You can have angles that are negative if we're doing our graphing in standard position. But it's possible to have an angle that is 5.6 degrees. It's just tiny. But I want to do some cross multiplication. So I get y sine of 51 equals 50 sine of 5.6. And I don't even have to do any inversing here. I'm just going to divide. So y is going to equal this 50 times sine of 5.6 divided by sine 51. And if we put all of that in our calculator, being careful that we have correct parentheses, we get, that y equals 6.28. So I'll put that up at the top where I have my other answer. And we have found all of our sides. So a lot of the times we may have to start off a problem using the law of cosines, but we can finish it if we're finding more than one piece using either the law of sines or just doing some subtraction of our angles if that's what we're looking for. But if it's not a right triangle, I can't use Pythagorean theorem. I am stuck using one of these two options, either the law of sines or the law of cosines. Homework is due on Wednesday night this week, not Friday night. We have a shortened week because of Good Friday. And then our test is on Thursday. So your homework is due the day before your test. We're reviewing class on Wednesday. If you have any questions, please let me know.